The recording is started. Hello everyone, if you are listening to recording, this is Jan 17th. We were doing in sessions on introduction to ZOS system programming, and Saurav and Prabal did the session 1, and this is session 2. Over to you, Saurav and Prabal.
Yeah, hi everyone. Good morning. Just give me 1 minute. Right. Good morning, everyone. Thanks for joining. Myself and Prabal are here. And last time we spoke about core pieces of system programming, what runs the system, and why stability matters. We also touched SMP briefly, and we noticed a lot of interest and follow-up questions around it. So today, based on that interest, we will revisit SMP, this time in a bit more depth, and with we are with real life perspective. And towards the end, we will connect this to where mainframes are heading next. That is, we all know that is mainframe modernization. So let's start with the SMP first today. So while we may not be able to demonstrate everything practically, today our goal is to give you the best possible understanding of the core concepts of the SMP. So, team, whenever we talk about installing software, right, applying fixes or maintaining the ZOS operating system itself, SMP is always involved. SMP stands for System Modification Program Extended. This is the full form of the SMP. But more important, it's a very core component of the ZOS system programming. So the goal today is to help you understand why SMP exists, how it works internally, and how we as a system programmer actually use it in real production environments. We will start with the basics, very basics, and then walk through the receive, apply, accept life cycle, along with some operational best practices we have to follow in a day-to-day life or all the time. Uh, Okay, so by the end of this session, you will be able to confidently answer three questions: why SMP is mandatory on ZOS, what actually happens behind the scenes during maintenance, and how SMP protects overall system stability. And before we go further, there are two key points we should always remember about SMP. SMP is not optional, it is the official IBM supported mechanism for maintaining ZOS. Okay, so SMP is delivered as a part of ZOS by IBM. You do not buy it or you do not purchase it separately. It's coming, we are getting delivered SMP as a part of ZOS by the IBM. So with that, let's begin by understanding why SMP was needed in the first place. So yeah, okay. So we all know a ZOS system is not made up of one program or one individual component. ZOS system is made up of thousands of individual components. What are those individual components we have? That we have load modules, macros, source, and control blocks. So we all knows what are load modules, macros, source. Source is like human readable code program written by the programmers. Macros is something shortcut or template which can be reused again. Okay, a load module is like a executable program stored in a load library, right? So ZOS consists of ZOS build. ZOS is being built by these many individual components. Okay, and over the time IBM releases fixes, enhancements, and updates. Why IBM is releasing fixes, why IBM is releasing enhancements, and why updates. So I'm using one product on one LPAR, on one mainframe server, but I need some security patches to get applied. I need a new functionality to get delivered to me. So IBM is releasing those fixes, those enhancements, those updates. Without proper control mechanism, tracking what is installed, I mean, what depends on what, is very, very tough, right? So SMP will come here, That's exactly why IBM provides us the SMP. So we discussed SMP is the primary IBM supported tool used to install and maintain software on ZOS. At very high level, SMP does three critical things very safely. Selects the correct level of code to install the code safely using system utilities, keep a complete record of what was installed, when and how. And SMP can be used by the two ways. One is batch mode, other is the SMP dialog or the ISPF dialogues, which are very useful for the queries and learning. So, team, did we get the uh, very simple definition of SMP? Why? What is SMP? It's a very core part of the ZOS operating system. It's coming, I mean, internally with the ZOS. No need to buy it separately. This is one. Second, the basic definition says to us SMP is used for installing, for maintaining the software, and for doing fresh install. Everything you want to do on ZOS operating system, ZOS server, any product, any third party product, be it of BMC, IBM, Broadcom, ASG, SMP is always involved. You have to install the products, you have to maintain the products through the SMP. And SMP is the primary IBM supported tool. Any questions here? We will understand it in more deeper, but just understand the basic definition of the SMP. Okay, so let's proceed further. So when all the tracking information is stored in a database called the CSI. CSI is very important concept of the SMP. Okay, CSI is like not a database like we have DB2, Oracle, like extra, right? I mean, don't consider it as a database. It's a vsam ksds dataset that SMP uses as its database. So why I call CSI database? SMP uses CSI exactly like a database. It stores record, maintain relationship, track history and dependency. So in conceptual terms it behaves like a database, but technically it is implemented as vsam ksds. We will go deeper into that in the next section, but just understand CSA is very important in SMP. It's not a database like DB2 Oracle. It acts as a database for the CSI because it stores the record, it maintains the relationship, its track history and dependency. Without CSI, SMP is nothing. Okay, so you need, if you want to ask something from the SMP, if you want to gather information from the SMP, CSI is needed. Without CSI, you can't get the information. Without the, I will change my words. Without the correct CSI. Okay, so and I mean when I say that SMP is useful in doing the install, so we can ask one question here, a natural question, that is, how does SMP know what to install? We don't just tell SMP, okay, boss, just install IMS. Boss, install DB2 for me. This is the version. Please do that. No, SMP will not do that. SMPs need something it can read, validate, and track, and that something is called a sysmod. So, uh, in layman terms, if I say, you can think of a sysmod as a language SMP understands. It tells SMP exactly what to install, where to install, and how it fits with everything else. Means if we explain it more deeper, okay, let's say one example. We as a human needs a language to understand the instructions, right? Means if something is coming in a paper and written to us and we understand, okay, these are the instructions written to us. Similarly, SMP also needs instruction in its own format. That instruction set is a sysmod. A sysmod is a sealed package of change. Inside it, what files needs to change, which load modules, macros, source are affected, what must already exist without installing. All informations are present in the sysmod. SMP doesn't think or assume. It reads and enforces rules written inside the sysmods. So technically we can say a sysmod is a package of changes that SMP used to install. Or in very simple words, SMP is how IBM deliver changes to the system and how SMP control these changes safely. So if IBM wants to deliver some PTF, some enhancement, um, uh, then IBM will do that in the form of the sysmod. And SMP knows only about sysmod. SMP understands the language of sysmod. So every change in ZOS, whether it's new feature or a bug fix, comes into the system as a sysmod, and SMP manages this. Any question till here? We understand about sysmod. We understand about SMP. We went into little basic on the CSI definition. Okay, let's proceed further. Now we know that what a sysmod is. The next step is to understand that not all the sysmods are the same. There are types of sysmods we have, and SMP knows those type of sysmods. One is function sysmod.
Prabal, one question about CSI. Is it a
Is it a
persistent storage? It's a
persist?
DB persistent, or it will be for when you reboot it, data goes.
No,
It's a
no, no.
permanent storage is the question.
Yeah,
Is it
yeah.
stored
It's a
somewhere?
permanent. Yeah, yeah. It keeps.
Okay.
It keeps record all the time. Yeah.
Okay.
Nothing will happen with reboot and all. Okay. Any other question, Savitri? You understand the things, right? What?
I understood. Understood. The
Yeah.
only question I had is that.
Yeah, that's fine. Yeah, yeah. Okay. Right. We were discussing type of sysmods. Okay, and SMP knows about these type of sysmods. We have four type of sysmods as we have as probably sharing in the slide. One is function sysmod. Okay. A function sysmod is used to introduce new functionality. Whenever IBM releases a new product version or major enhancement, it comes as a function sysmod. So I'm using IBM, but there are many other vendors also, Broadcom, BMC, Rocket, right? So whenever any vendor releases a new product, right? Okay. So a major enhancement, it comes as a function sysmod. Like let's suppose we have a new ZOS release, we have a new IMS or Kicks release, we have a new control scheduling software release, major feature enhancement. So then a new FMID will get released. Function system mode, you can consider it as a new capability. Okay. Now second is PTF. PTFs are IBM supplied fixes. Okay, used to prevent or correct problems. This is one statement. Okay, even though I say okay, PTF. If you see in the slide, did I mention? No. PTF stands for Program Temporary Fix. Okay, these are the IBM supplied fixes used to prevent or correct problems. Even though I said temporary, but in reality, PTFs are the standard permanent way IBM deliver fixes. Okay, so whenever you apply the PTF, you are applying the fix permanently. Means you can roll back it again, but in nutshell, you are applying it permanently. That problem will not arise until you are not doing anything else. But if Savitri is facing some problem in one of the mainframe tool she is using, right? So she will go to the IBM. She will ask a PTF for that. If PTF is delivered, if PTF is released for that particular problem, she will apply it, and then that problem is gone permanently. Okay. So means problem means bug fixes, yes. But if Savitri needs new improvements, new enhancements, new features, or new security updates, that will also go through a PTF. And in our real life, most of our day-to-day SMP work revolves around the PTFs. Okay, so just understand PTF means IBM approved fix which we can trust. Other vendors also. Means I'm just taking the example of IBM, but whenever I say IBM, I means PTF is not for IBM particularly. All vendors follows the same approach. Right. Okay. Now third is APAR. So APAR is something like uh, uh, I mean just understand this. First of all, APAR leads to a PTF. So whenever customer reports an issue, okay, IBM or any other vendor opens an APA to track and analyze that problem. Okay, if the issue is critical, IBM may provide a temporary or interim fix quickly. Once that fix is fully tested and validated, it is packaged and delivered as a PTF. So if Savitri as a customer opens a case with the IBM, okay, and somehow that problem is very critical, and it is getting resulting in SLA delays, or so many things are happening, and or maybe IMS reason is not coming up all the time safely, and it's getting after some hours, it is getting down automatically, so you need to immediately fix. Simply you open a case with the IBM, whatever IBM will opens an internal case with the internal team, and then they will open a APAR, but you need the fix as soon as possible. So you can't wait for the PTF for all the testing and all those things. You ask the IBM, give me the fix now. So IBM will give you the fix in the name of the APAR. Then this APAR, after some testing validation, leads to a PTF. Okay, so APAR is like a problem record, and the PTF is the official fix. So if I say APAR usually represents urgent problems, which is why IBM often delivers an earlier fix quickly, later formalized as a PTF. Number four type is user mode. Uh, User mode is used to customize IBM software. Okay, either by modifying existing IBM code or by adding your own written code. I'm using one software, but somehow that software I want some extra functionalities, or that software is not getting along with my system behavior. I want to modify something. Then that how I will do with the help of the user mod. That is user modification. It is typically used when the default IBM behavior does not fully meet the site specific requirements. Site specific, I just take an example of that, right? So a user mod can be used to replace or update an existing IBM element, introduce a new user written module, tailor IBM software behavior for local requirements. Okay. I mean, it's give us the great flexibility. Okay, I have developed my user mode in my system. Now that software is behaving as per my requirements and specification, but it will increases the maintenance responsibility for me. Why? Because anytime we apply PTFs or upgrade a release, we have to revisit and reapply our user modes all the time. If you miss it, your system, your product will not behave whatever you have configured it last in the previous version.
Here, PTS means maintenance.
Yeah. So, I mean, if I talk about me as a system programmer, I always try to minimize the user modes and manage them very carefully, because every user mode becomes our long-term responsibility. It's not that we are doing it for 1 year, 2 year. Means as soon as the system is up, or as soon as that product is running, you have to apply those user modes all the time. I mean, until the clients don't need that behavior now. So in the end, if I summarize, function means bring new features, APAR responds to a specific problem, PTF delivered the official fix, user mod means local customization. Means I will do my customization, user modification. And SMP understand all these sys mods. If we go to the slide 5, let's just go back probably one time. Right. In the end, I have bolded. So BCP is internal ZOS component. If you see, for 2.5 BCP and for 3.1 BCP, we have a different FMID. So that gives example of the function sysmod. See, for 2.5 FMID is different. For 3.1 FMID is different, and SMP knows these things. Okay. So for 3.1, we can't have the same FMID whatever we have for the 2.5. So each version, each new upgrade, each new version release, each new major enhancement release will give us a new FMID, and that is very unique.
It becomes the identity for
Yeah,
that product.
Yeah, it becomes the identity. SMP doesn't know, okay, control scheduling software. SMP knows that this is the scheduling software, or what this product is named as through the FMID. SMP knows about FMID. Let's go to the slide number 5. If you see this is the sysmod example, particular, I mean, one of the sysmod example we have. Okay. So if you see the first line, UZ0004 is the PTF number. Okay. The plus plus PTF statement tells SMP that this sysmod is a program temporary fix. Okay. If you go to the second version and then the FMID, FMID stands for the one of the mainframe product. uh, we don't know, we can be, if you don't know this FMID, you can Google it also, with the name and says FMID, and Google will give you the answer to which product this FMIDs belong to also, right? Because for us, we understand it with the name of the product name, but for SMP, FMID is everything. Okay. So this definition in this telling us that this PTF use a 0004 applies to this specific function product. Okay, that is FMID FXY1040. So automatically with this sysmod example, SMP is reading it. Okay, this is the PTF, this is the version, this is the FMID. If FMID is different, see the FMID number changes FXY1050. Sysmod definition is telling the SMP, then apply another PTF. Then that PTF is not in use. Okay, then that PTF may not be needed. But if your system maintains FMID FXY1050, then you need to apply use a 4 times 05. Savitri cannot apply use a 4 times 4 PTF to the FMID FXY1050. Okay. We are not telling the we are not maintaining any document for that. We are not feeding any information. We are SMP is already getting the information with the help of the sysmod. Okay, and then it's also telling the SMP which with the help of this PTF, if FMID is 1040, with the help of this PTF, this module under this distribution library is getting replaced. Plus the macro is also getting update under this distribution libraries. So this is the typical sysmod example. Right. So let's go to the, we can say like, yeah, we can say like this, uh, from this definition, SMP knows what type of sysmod, this is PTF, which product and which version it applies to, what dependencies must be satisfied, which modules and macro will change, how libraries are affected, how to track this change permanently in CSI. Okay, so FXY1040, FXY1050, it's similarly like it's not a ZOS version FMID, but you can consider it one product is on something like 1.4 version and another is on 1.5 version. It represents something like this. Okay. What next we have?
CSI is in
Okay.
detail.
Any question till here? Ask any question. I mean, if you any basic question also.
Who updated that sysmod and all before that? Yeah, actually, who update that one? This is a version. This is FMID. Somebody has to feed, right? System
Yeah,
ad.
developers, software developers, they are making the actually the PTFs and the APARs.
Okay.
Okay, so our role as a system programmer is to apply them in the system. Software developer role is to make them. Okay, and if Savitri is a customer, then you need this PTF. You saw that, okay, this PTF is needed for the security purpose. You will or okay, let's take example, very basic example. Savitri is facing one bug in his product. Okay, she opens a case to the I let's suppose that product is of IBM. She open a case to the IBM. Now IBM L2 support person will open a internal ticket, and then this software developer of that product, particularly let's suppose the IMS, okay, will see into that problem, will make that problem in their system again, and they will realize, okay, this load module is getting impacted or this load module is getting corrupted, and then we have to solve this load module, and then they will open a new PTA for that. Whenever they open a new PTF, they will feed all those informations in this. Okay, this is the PTF name, and for to this FMID it belongs to, and this PTF corrects this particular problem. Okay, so our role is to apply them. Developer's role is to uh, make the PTF, whatever the problems we are having, or what are the new enhancements they need in their product.
Okay,
Okay,
thanks.
thank you. Give me 1 minute, please.
Yes, I
Okay, so now that we understand sysmods and their types, the next big question comes to us: where does SMP keeps all those information? We touched a little in the start. We know the answer of this. Where does SMP keeps all this information? The answer is CSI. CSI stands for Consolidated Software Inventory. CSI, it acts as a brain of the SMP. Okay, if CSI is wronged, if CSI is damaged, SMP cannot function correctly. Without CSI, SMP is nothing. Okay. So CSI is a vSAM dataset, okay, that contains the complete inventory of the software installed on the system. It does not store the actual programs, it stores the metadata about them. CSI tells SMP what is installed, where it is installed, and in what state. So particularly this is a vSAM dataset because for performance, for integrating, and for recovery. CSI is logically divided into three zones, each with a very specific responsibility. Okay, think of CSI zones. How can I say? Like a like roles in the organization. Okay, one zone controls, one zone runs the system, one zone keeps the backup. Each zone knows its responsibility. Okay, global zone knows what he has to do. Target zone knows what he has to do, and distribution zone knows what he has to do. And SMP coordinates with them. Okay. So if we go to the first zone, the global zone, okay. So global zone is acts as a control center of the SMP. It knows which target and distribution zones exist. It tracks his status. This is also where whole data is stored. Whole data, we will understand it in more deeper later, but it's like information about fixes that should be delayed or handled carefully. That means we look at one example in the top, like use a 0004. With that, some whole data can come. So whole data is like information about that fix. Okay. Before you apply Saurabh that PTF, can you please look at that whole data? Means maybe that can be an extra actions for us, or maybe that can be warning for us. Okay. Maybe after we apply the PTF that needs an IPL. Maybe after we apply that PTF, some binding is needed, or maybe some documentation update, some enhancement, anything. Okay. So all those information we will get in the whole data. Now, okay, so target zone, global zone means control center. Okay, uh, and now if you come to the target zone, it what's the system runs. Okay, target zone represents the software that is actively running on the system. Okay, so target zone means where the system actually uses. Means what the system actually uses. If you want to run the product, you don't need the global libraries. You don't need the distribution libraries. Let's have the target libraries. Your product is going to get function. Okay, your product can run. And distribution zone holds the master copies of all the software elements. Okay, means very clean, very unmodified copies, which we are doing it in the when we are doing it the first time. It can be used for recovery. It can be used to rebuild the target libraries if somehow you that libraries got corrupted, so we can rebuild it with the help of the distribution zones. Okay, so global zone controls everything. Distribution zone stores master copies. Target zones run the system. So far we talked about sysmods, CSI, zones, and libraries. Now let's see how SMP actually processes these changes. Okay, what are the three basic commands? It's not IBM. Every installation follows the same sequence, the three basic commands. Okay, so I means so every change flows through three steps. One is receive, second is apply, and third is accept. And SMP tracks everything in the CSI. So with the help of this control flow, right, the three steps, receive, apply, and accept, this is what keeps the mainframe system stable even while they are constantly, or while we are constantly changing it. Okay. What do you mean by receive? In very basic terms, bringing something, right? The first step is to receive, bring it. Okay. So with receive, bringing changes into the SMP. Sysmods are received from IBM. I will take IBM example, but many vendors are there. Okay. Stored in SMP datasets, not installed anywhere yet. You have just received it. Receive only brings the sysmod under the SMP control. At this stage, no system libraries are touched. We just receive the sysmod in our global zone. Okay, now my global zone knows this sysmod is received. That's it. But this doesn't mean that you have applied it. You have applied the fix. Savitri has applied the fix. No, Savitri has just received that fix from the IBM vendor to his local or to his client system where she has the SMP datasets. Now, second is apply, installing into the system. Okay, sysmod are installed into the target libraries. Executable code becomes available to the system. CSI is updated with the installation status. So before actually installing or before go for the apply, we usually run the apply check. So apply means now whatever PTF sysmod we have received, we are actually hitting the libraries with the changes. Okay, we are actually modifying some load modules of that product, or deleting these old load modules, or updating the existing load modules, or adding a new load modules. Anything can be happen with that apply. Okay, many other changes are also there. Macros, sources are also getting updated. Okay, so but before you do the apply, before you actually do the edit of the target libraries, we always run the apply check. Okay, apply check simulates the install and tell us what will change, what pre-requests are needed, and if there are conflicts. Okay, so apply means put the change into the running system. Apply check means dry run. You're not doing anything. You are just checking the system. Okay, whether all the pre-requests are okay, whether my SMP datasets are correct, whether the SMP knows all the things, whether can be any space issues are there or not. With the help of this apply check, you will get the answers. Now the final step is accept. We studied about receive, we studied about apply. Now the accept, making the changes permanent. Okay, moving the changes into the distribution libraries. Okay, with apply you are moving the changes into the target libraries. Okay, mark sysmod as permanent, update CSA accordingly. Okay, accept means this change is here to stay forever till that product runs, unless you're not doing anything with the CSI, or you're not going for the another CSI. Okay, this will mark as a permanent change. So about the chart on the right, if you see, we spent some time. Okay, so receive is least risk for us. We can receive it very quickly. Apply is most time consuming, because this is where we are hitting the libraries, so we have to do many pre-checks and many other things we have to see. Okay, except very control and cautious. Is it's not that all the time you need to accept the PTFs. Okay, there is no need to accept the PTFs. You can apply it, your target libraries are getting modified, your product will run. Okay, verifications, yeah, once we do the receive, apply, and accept, I will not say, we will not accept the PTFs. Okay, but when you are doing the base install, when you are doing the fresh install, we are accepting the FMIDs, and with that FMID some base PTFs are getting uh, accepted also. So question, why we are not accepting the PTFs? Because that PTF today what Savitri is applying, okay, what I am applying as a sort of, I'm applying some PTF. That PTF after 4 months, 5 months, 6 months can become a problem in error, PTF. Okay, with that PTF, some another bug is coming. So that's the reason we are not applying the PTF. And once you accept it, that then there can be no rollback. Contract is signed, you are done. You can't go back with that PTF.
There was a raised hand. I guess somebody has some question.
Okay. Yeah. Anyone has any question? Okay, we will go. So in one sentence, SMP processing works like this. We receive the
Uh,
change, apply.
Yeah, yes, yes, Saurabh. I have one question.
Yeah,
Sorry
yeah,
to interrupt.
yeah. Please go ahead. Is
While
it
apply
Kavi?
checking, yeah, yes, is it?
Yeah,
Kaviyasan here. While
yeah,
apply
yeah.
checking, there are more than 5 to 10 target libraries. How to find the part while applying the PTF for a particular target library? More than 5 to 10 target libraries are there in when apply checking.
Okay. So your question is, while applying check, how to identify the target libraries?
Yes, there are more than 5 to 10 target libraries in our system.
Okay.
How to find a particular PTF target library?
You don't have to find it. PTF will SMP will do it for you.
While SMP while apply checking, we need to select those target libraries, right, while running the job. So
While
on
running
that,
the job, while running the apply check or apply, you need to mention the target zone name. Okay, you
okay.
will you will
So
mention the you will mention the CSI name, and then after that you will mention the target zone name. With that,
okay,
SMP will understand what uh, under that target zones we have ddefs. Okay, so that is data definitions. Through the help of those ddefs and through the help of the zone name, through the help of the CSI name, as your job automatically will understand which are the target libraries she has to hit. And it's not that with one PTF, all the 5 to 6 target libraries are getting impacted. I mean, assuming those 5 to 6 target libraries are only for one, for the same product. Okay, we can have many target libraries, right? Some products
yeah,
have 20, some products have 10, some products have 5. Okay,
okay,
so with one PTF or with two PTF, there can be a case only one target library is only getting impacted and rest are getting unchanged. So once you run the apply check, you will get a report in the last. You can see in the last which are with this PTF which module is getting impacted, where it is getting impacted, and which libraries it gets impact. No need to change or do anything in the other libraries. Only one library is getting impacted. Okay, do the change there only.
okay.
So
How
answer
to
to your question,
identify that
yeah.
one library particularly? How to identify whether which library is affected? How to
Okay,
find the target
yeah.
library?
So once you run the apply, right? Once you run the apply check, if you go to this pool and if you see there in the last, in the, I guess there is a SMP report will
Yeah.
be there. So once you open that in the last, if you go there, let me share my practical experience. Okay, so you go there, type S and go to the last, and then do F7. There will be a data sets coming there. Okay, what are getting impacted, what are not getting impacted. From there,
Okay,
you will get an answer.
You can check
okay,
it for all the modules, all the PTFs you're applying in that particular apply or apply check job, and what all modules are getting impacted and where those modules reside in what target libraries. And then corresponding to those libraries, you can go and check that yeah, they have been changed, there have been some changes, and then you can take them along as part of your change.
So
okay.
there can be multiple data sets which are being getting affected. So we can
Yeah,
say through the SMP report log
yeah, yeah,
that tho-
yeah.
all those files are getting affected, right?
No, I mean it depends to PTF to PTF. Not with, I mean, sometime with some PTFs, all target libraries are getting impacted. Sometimes with some PTF, only one or two target libraries for that particular product is getting impacted. It's not like that all data sets are getting impacted, but but something some will get impact for sure, but not all.
Yeah, so that is the question. So how do we know that which is the current library getting affected? So if we see if you go to the logs SMP report, so
Okay.
there will be multiple data sets which are getting. It shows multiple data sets getting affected. So how to identify the which is the main one? That is the question.
Okay, I can show this to you, but I don't have system in front of me. But I don't know if I can tell anyone also
We
to
can,
share the
um,
screen. But if you go to the SMP report, right, in that job itself, and in the last, if you go and then if you come up, you can see there the changes. What are the changes are getting hit? How can I say? We will search it with some. Okay, apply. Means okay.
up-
Number one thing, target libraries are always starts with S. Okay, so
Okay.
uh, and distribution libraries are always starts with A.
okay.
Okay, so we have to make sure that S only, right?
So Anurag, we can take it offline. We can probably
Mhm.
check one of your jobs, apply jobs output, and we can show it to you how you can notice the changes there. What all target libraries have got impacted.
Okay, okay, sure.
This is in interest of the rest of the audience and time.
But
One
yeah,
more question. Is the prerequisites and core requisites are same or they are different?
no, uh, those are different. And pre-request and core request, I will tell you in the further slide, but those are different.
Okay,
Different,
okay,
and SMP will always take those things. Those comes in the dependency, right? Tracking and all those things SMP will take automatically, but those are different.
okay, okay. Thank you.
Okay.
See.
Okay, so this is a much more deeper into that. We will fast track it now. So in the diagram, if you see, you can see the sys mods coming from the external source, right? They are received into the SMP datasets, SMPP, TES, SMPT live, and information is recorded into the global zone. Okay. Um, so I mean it's very simple. We just explain it now. Website and that disk from where you are getting the files electronically on your system. Okay, receiving it and in your SMP datasets, which are SMP PTS and SMP TLIV. Okay, whole data is also there. SMP checks for whole data like error, hyper, or special instructions. And if you go to the slide number 9. Uh, Apply is the phase where actually system libraries are modified. Apply installs sysmods into the target libraries. The libraries the system actually uses. Okay, load modules updated, macros updated, CSI updated in real time. So if you see SMP copying the elements from staging datasets we just explained before into the target libraries now. Okay. So at this moment, distribution libraries are still untouched at this point. After apply, the system is running with the new changes, but they are not yet permanent. Okay. And why we are not making it permanent, we also learned about this. Now in accept is the point of no return. Contract is signed. Okay. Accept moves the install changes into the distribution libraries. Okay. All temporary informations are getting cleaned up. You can see here, the elements are copied into the distribution libraries and CSI entries in the global zone and distribution zones are updated. Once you accept this is PTF, that information will get deleted from the global zone. So target libraries remains unchanged during the accept. Okay, temporary data sets, obsolete entries are getting cleaned up in the while you do the accept. So up to now, we have seen how SMP install and finalizes changes, but in real production environment, things can go wrong. Okay, so this slide shows SMP how SMP help us detect problems early and recover it safely. Okay, so whole data it is the first line of defense, that is whole data. Whole data is IBM's warning system. Okay. Again, I'm taking IBM name, but there are many other vendors also. Before SMP install a fix, IBM may attach a warning notice telling you to stop, check, or take action first. Okay. So for SMP, it says I can install this PTF, but you should read this warning. SMP acts like this. I will say something this to us. Okay, boss, I can install this PTF for you, but you should read these. Some lines are there in the whole data. You should read these warnings. Okay. So in simple definition, whole data is a special control information supplied by IBM that identifies conditions requiring user review or actions before a sysmod is applied. Then we have a type of whole data. PE means the fix itself is broken. IBM found a problem in that PTF after releasing it. In the above slide somewhere I said about PE. Okay, programming errors. Okay, so after releasing the PTF, some bug comes which was not identified earlier, but after 3-4 months of using it, some bug come, and suddenly that PTF which Anurag has applied for the security vulnerability has become a PE now. Okay, so if Anurag has accepted that, he can't roll it back. He has to apply a new PTF. But since Anurag has applied, he can roll it back with the help of restore and reject. Okay. So PE whole data indicates that a PTF has been identified as introducing a program error and should not be applied. Okay. So this information also will come in the whole data. Okay. Hyper whole data means hyper means serious impact. Hyper whole data identifies PTF that resolves high impact or system critical problems. Then we have security whole data. Security means vulnerability. There is a security exposure if the PTF is not applied. Okay. So PE means fix has a defect. Hyper means high impact issue. Security means security vulnerability. PE means do not apply, hyper means apply with priority, and security means apply urgently. So these are some types of the whole data. We always review whole data before apply because SMP install fixes, but whole data tells us the actual risk. Okay. So if you go to the reject and restore definition, restore is a SMP command, we can say, like we have receive command, apply command, and accept command. Restore is another SMP command used to back out the sysmods that have been applied but not accepted. Okay. So if you have applied some sysmod and you want to roll it back, you don't want that PTF now, you can achieve this with the help of the restore SMP command. Okay. So restore backs out the install changes. Now reject. Reject is another SMP command used to remove sysmod from the SMP control records. Means control records means the global zone, the receive zone. Okay, or the SMP PTS dataset where the temporary PTFs will get sit once you order the files from the vendor. Okay, so reject is again a SMP command used to remove a sysmod from the global zone, from the receive status. Okay. Recovery? Yeah, recovery we have. Okay. Once a sysmod is accepted, there is a no SMP command to remove it from the distribution libraries. This is critical and absolutely correct statement. Okay. I will read it one more time. Once a sysmod is accepted, there is no SMP command to remove it from the distribution libraries. Okay. Beyond SMP commands, we always rely on the system level recovery, or we can say as the best practices we will follow. Uh, so we will take dataset backups, volume restore, or maybe sometime the DR procedures also we will follow. Okay, so so before you go for the apply, take the backup of that previous version of the target library. Okay, I mean, so you can do the apply check. Again, I will come to that point. Go to the SMP report, look at the datasets which are getting impacted, and target libraries are starts with the S, and distribution libraries starts with the A. So look at the target libraries which are getting impacted. Okay. Anurag says three libraries are getting impacted. I saw in the SMP report through the job which I ran, which is the apply check, and then he comes back to the system. He took the backup of all those three libraries, and then he went for the apply, so that if anything happens, if apply doesn't work, or if anything happens, he can restore it back from the best practices, from the backup he has. Okay, so SMP protect us at multiple levels: through the whole data, SMP warns at before change; through the restore, undo the temporary changes; through the reject, remove the sysmod records; and recovery, that is the last line of defense for a system programmer. So with this, we have covered the complete SMP lifecycle, from receiving the changes, installing them safely, finalizing them, and then recovering whenever we need. So slide 12, let's look at the actual SMP datasets that make all of us this work. Okay. So these datasets, SMP CSI, SMP PTS, SMP LTS, these datasets exist on disk, okay, as a system programmer, and we interact with them directly, okay. So SMP relies on small number of critical datasets, and each has a specific purpose for that, okay. So there, I mean, when you talk about SMP, right? So there are three type of datasets. One are SMP datasets, other are target datasets, and third are distribution datasets. Okay, SMP datasets, that's what SMP needs. Target libraries are the datasets, are the that what a product needs to run it in the system. Distribution datasets are the datasets that if that the that acts as a master or the clean copy. Okay, for us. So if you look at the SMP CSI, we have discussed this. It's a CSI stands for Consolidated Software Inventory. This is a vSAM datasets, stores relationship dependencies like pre-request and core request, whatever we discussed, and the status. If SMP CSI is unable or corrupted, SMP cannot function. Okay. Then we have SMPPTS. This is the temporary holding area. Once when a time Anurag is receiving the PTFs or the relative files from the vendor, the first time it gets stored during the receive phase in the SMPPTS. Okay, hold the sysmods that have been received, acts as a temporary storage. Nothing is active yet. Okay, so sysmod in SMPPTS are not applied in the system; they are in the receive status. Okay. SMP LTS contains the base version of the load modules. Okay, clean origin copy is used as a reference. Okay, and we have some additional support datasets also that works behind the scenes. These datasets don't set the logics, but they are critical for storage, recovery, and staging. So one is SMP CDS, and then SMP MTS, SMP STS, and SMP TLIF. Okay, SMP SCDS stores backup copies of the target libraries which got created during the apply. Okay, we use this dataset if means not we SMP use these datasets if an apply fails. Okay, SMP automatically will safely back out the changes with the help of this. Okay, SMP MTS stores macros shipped with the IBM product. Okay, these macros are used during the assembly to build the programs. Okay, we all knows that if an assembly fails, right? If an assemble fails, sorry, because a macro is missing, we know that which datasets we have to hit. We have to look at the SMP MTS. One of the first place we will check. Okay, so SMP MTS hold the macros. SMP STS is the SMP dataset which keeps the original source code. Okay, so when a vendor ships a source level fix, SMP STS is where that source lives. SMP TLIF is temporary work area used by SMP during apply. We don't use it, but SMP, whenever you run the apply, right, or accept, these datasets are getting being used. Okay. Uh, it's like a staging table where SMP prepares changes before placing them into the target libraries. Okay, SMP manages automatically, and nothing is permanent here. These are temporary, very short-lived datasets. Till the time your apply is running, these datasets will be there in the system. As soon as apply ends in failed or in successful status, these datasets are getting deleted automatically. So right, so during maintenance, Source and macros are read from the during maintenance, means whenever we apply the PTF for doing anything on the product. So source and macros are read from the SMP, MTS and STS. Temporary work happens in the SMP TLIF. Updates go to the target libraries and backups are stored in the SMP SCDS. So let's say, example, IBM finds a problem in IMS load module, okay, that sometimes cause an event during startup. So IBM will deliver a PTF to fix this issue. That PTF is packaged as a sysmod. Now we break that one sysmod into the three parts. So I'm talking about the slide number 14, okay. So there is a problem now. My IMS is getting a bend. It's not getting startup, and some of there is a problem in the load module. Maybe it's get corrupted. We don't know. System is not able to read it. So for that, we reach out to IBM. IBM delivers a PTF to us. PTF means that PTF is packaged as sysmod. We understood all those things. So now what is that sysmod is, we will understand, we will break that one sysmod into the three parts. How SMP will see that sysmod, okay. So one part is modification control statements, that is MCS. This sysmod tells SMP what it is and how to handle it, okay. Example, we have seen this is mod ID, the PTF number, the type PTF applies to IMS, which FMID applies to. Okay, these all things will come under the modification control statements. Okay, now there is another thing, that is modification text. This is the real change, the things that actually fixes the problem. Okay, means possibly an updated macro or object module, a new version of the load module. This is where all those things will get defined in the modification text. MCS tells SMP what to do. Okay. MCS tell SMP what to do. Modification text contains the code. Okay. The target libraries are where the code finally lives and runs. Okay. So SMP, MCS will give us the picture. Okay. SMP will understand. Okay. This is the PTF number. This is the FMID. This is to which zone it is getting applied. Is there any pre-request? Is there any core request? No. Then this will get, and SMP will understand with the help of the MCS statements. Now actual code content will be there in the actual load modules, macros, source will be there in the modification text. Now there will be third dependency. This SMOD must not be installed alone or out of order. Pre-request means it's required IMS base this, and core request means must be installed together with this, right? Means
This was the question as well from Anurag.
yeah, okay.
Prereqs and correct.
So SMP checks dependency to make sure we never install half a fix or mix incompatible code levels, right? So you can't apply a PTF of one version to the other version. If one PT if they if we are applying B PTF, okay, but for B PTF, SMP says to us that okay, A is also needed. A must be in apply state. So SMP will check itself when you are applying the BPTF, whether that APTF is there in the SMP in our CSI, in our product or not, in this in apply status or not. If that is not applied, if that is not received, SMP will not go for the B apply state. Okay, it will get a fail. As it says, it's missing P request. It's required this PTF. Okay. Okay, maybe in layman term, if I say, I don't know whether this example will go fine or not, but if you say Sysmod as a medicine pack, okay, so if you purchase any medicine, okay, so the labels and the instructions are something what are MCS, okay. The actual medicine, what we eat is the modification text, okay, that will actually do the things in the background, okay. Other MCS are instructions, modification texts are actually the actual medicine, and dependencies are something, the warnings about okay, you should not take this medicine below the age of this medicine should not be taken, something like that, okay. So those can be treated as a dependency. So we are into the last slide of the SMP. Shows, we will say, how the SMP rebuilds a load module when a fix is applied. Fix means when a PTF is applied. I'm not going into the two level detail here, two level detail here, or two deep level detail here, but just the flow, just the basics, what I have also learned while doing the SMP process. Okay, so whenever SMP needs to rebuild a load module, okay, the first thing it does is figure out what inputs are required. What is the input? Okay, um, uh, uh, that input can come from different things. It can be source module shipped into the sysmod. It can be macros. It can be source text from SMP STS, or the information from the sysmod, or the existing object modules. Okay, once it gets the input, then the second phase will come to the assembly process. SMP does not assemble the code. Okay, instead, SMP generates a temporary JCLs in the background and call the system assembler. Okay, okay. Macros are expanded, source is assembled, and object modules are produced in this stage. Okay, assembler will create the object modules. First, it will take the input from different places, from SMP MTS, SMP STS. Okay, the information from this is mod, and then the SMP will go to the assembly phase. It will not assemble the code by itself. It will generate a temporary JCL in the background and calls the system. Okay, call the ZOS. Okay, can you do this as a assembly process for me? And then the system will do, and then with the help of that assembler, the object modules are getting created. Okay, now the third is link edit. uh link edit means link edit binder. That in general, that means combines them into the load module. The SMP invokes the link editor in the background. If you see the apply job, okay, these many things are going into the apply job. You can read these informations in detail from the apply job, but in the background, these many things are happens. Okay, this step will combines all the object modules and create a single executable unit. Means that means the load file. Okay, so the load module creation is the very most important part. The final result is a load module written into the load library. This is what actually the system runs. At the same time, SMP records everything in the CSI, which sysmod build it, which FMID it belongs to, and what inputs were used. Okay, so this is how the load modules are getting rebuilt, and in with the help of the SMP. SMP does not do it by their own, but it invokes the temporary JCL. It takes the system help and all those things, and then the load module is getting generated. Okay, so if you go to the next slide, Prabal. So best practice. Uh, to close the session, I want to summarize. To close the SMP session, we still have one more session left. I want to summarize practically best things that actually keeps SMP environment stable in real life. Many people knows about this. So if maintain the CSI backups regularly, because CSI is everything. CSI is brain of the SMP. If CSI is gone, SMP is nothing. Without CSI, you can't even get a single information without the CSI of any product through the SMP dialogues. Okay. Um, so take regularly CSI backups. Backup before measure apply, except like we discussed before we go for the apply. We actually check in the apply check job through the SMP report, which other data sets are getting impacted, and then we will take the backup of that. Okay. Uh, use apply check before the permanent installations. Yes, we discussed that. Apply check is one of the safest feature in this SMP. Okay. I mean, in general, apply check tells us what would happen without changing the system. Okay, except is the point of commitment. Uh, Plan except operations very carefully. See if you have to apply this PTF or not. Usually, best practice says no to apply the PTF, but there can be some changes on in that also. But best practice says never apply the PTFs. It depends system to system also, or process to process, I will say. Monitor the whole data for issues. Whole data is IBM early warning systems. It flags to us known problems, required actions, special instructions must be reviewed before apply. Before apply and also after apply. They can be both action items for the system programmer. Okay. So that's it. What is this? Test modification before production. That means no fix should go to the production. Okay. You should test in the test environment, then the QA environment, validate applications and the system behavior. This will help us in reducing the production risk. Okay. So never ever apply the PTF directly into the production environment. Apply the PTF first in test system. If you have the same version and the same CSI and the same product running there with the same version level, apply it there, and then test it for one week, and then you can go to the another environment, so on. So thank you for the SMP session. I hope this sessions gave you both, I will say, conceptual clarity and the practical confidence in working with the SMP. These are the main core concepts, languages of the SMP. In the last slide, if you see, I have just attached the um, CSI names.
Second, let
Oh,
me reshare then.
probably just 1 minute for sure. Go down. Yeah, yeah. These are just the JCLs. Okay. Probably
One
share.
second, let me share.
Yeah, yeah,
So
yeah.
there you go.
Thank you, Prabal. So these are the JCLs which we will use for the creation of the CSI, initialization, receive, apply. In the if you see the receive, we are mentioning the global zone name. If you see the apply, we are mentioning the target zone name. Okay. Let's go to the next slide. We have a JCLs for apply check. For apply check also, you have to mention the target zone name, except you have to mention the distribution zone name now, because you are going to accept into the distribution libraries. Then we have restore, reject, list, CSI, all, I mean, replace, delete CSI, anything. Okay. So that's okay. We are uh, done with the CSI. Sorry, not CSI, with the SMP. And we left with the next thing, that is the future of mainframe system programming, or maybe the future of mainframe. We will take 1 minute break if it is fine, Santil. Just a few second pause will be there.
Yeah, yeah, take. Sorry.
Okay, team, I'm back. So we uh now we know about SMP, right? Just whatever we said about SMP, just make it a story. uh, uh, Keep in your mind in the story, do a SMP course, and then you will understand all the things about SMP. But it's very critical, very core component of the ZOS system programming. Without that, means we can't do the installation upgrades. As I discussed, there are many tons of thousands of load modules. To track all those things, it's very impossible for a human. So SMP does it for us. Now let's go with the modernization, which is going on from the quite um, I don't know how many years, but now we are hearing it a lot about modernization. Okay, so when we hear the word modernization, right, or when I hear the word modernization, what I immediately think. So it's uh, if we talk about any mainframe person, okay, so he will say, okay, oh, modernization, okay, is it mainframe is going to get retired? Okay, is it mainframe is getting replaced, or is it something is going to get rewrite on the mainframe? No, modernization is not about that. So we today we want to I will not say this challenge that thinking, but I will say that we will want to oppose that thinking, that with the word modernization, It's not that you are going to retire the mainframe. Okay, mainframe modernization is not about throwing what works. It's about involving what already works brilliantly from the past 50, 60 years, right? So IBM Z is like a solid vault, trusted for decades. Banks, airlines, government trusted, run mission critical workloads, has survived every technology shift. When cloud came, people said mainframe are dead, but it has survived that technology shift also, right? But today, world's demand. But one thing is sure, okay? Today in the world, every organization, every person, every developer, every technical person also, okay, demands the cloud speed, demands the APIs, demands the DevOps, and demands the flexibility. Okay, so mainframe modernization is the bridge that allows IBM Z to thrive in this new world. Okay, without losing its reliability, security, or performance. Modernization is the need of the time now. Okay, so let's be honest, if companies don't modernize, there will be consequences. There will be slow product releases, difficulty integrating with cloud and mobile apps, losing customers, losing market opportunities. So modernization is no longer optional, it's survival. And for me, if I say everyone sees the modernizations differently, okay. Senthil may have a different approach about modernization. We as a system programmer has a different approach about modernization. Application programmers, developers have a different approach. So similarly, everyone sees modernization differently. So if I say for a chief technological officer, modernization means faster feature delivery. Okay, for an architect, it means cleaner integration. For a developer, which it means give us the modern tools, give us the less friction time. For a security person, the modernization means stronger data protection. Same modernization, but different values for different roles. What modernization is not, it's many people think it's not about rewriting all COBOL overnight. It's not about moving everything off IBM Z. Not risky. It's not about big bang migrations. Okay, okay, okay. Think of modernization as a journey, not a project, which is very need of the time. It's a journey. It's not a 1 month, 2 month, 3 month deadline project, 4 month deadline project. No, modernization is a journey. If we treat it as a journey, then it's very successful, both to the technical person plus to the organizations. So journey model, if I say about, it's about learn, it's about adopt, it's about say deploy. Learn, learn means what? Understand the current system in deep and the possibilities to enhance it. Adopt, adopt the new tools we have. We have the DevOps, we have the APIs. Deploy means improve continuously, scale, automate the things, right? So modernization doesn't mean everything moves to the cloud. Okay, it means the right workload runs in the right place. Okay, the front end apps, cloud is needed, mobile web APIs, cloud, but the core banking transactions and data will be there on the IBM Z. So when you do a mobile banking transaction, okay, the UI is cloud to us. We are doing it through the mobile, okay, the UI is cloud. But the actual debit or credit still happens on the IBM Z. That's hybrid cloud in action. That is what modernization is. That is the need of the time. Okay. We are modern. Okay. So uh, if we, how can I say? I mean, uh, to move the data from the mainframe to other platform, it's risky, right? Then how we are guarantee the organization or to the stakeholders about these security things. Okay, so that the data never leaves the mainframe. What changes is how we access it. Earlier access was mainly through the green screen programs or the batch jobs. Today we access the same data, the mainframe data, using the REST APIs, JSON files, just like any other modern systems. Okay, so we know that in mainframe the data lives in db2 tables, vsum files, right? The business logics which developers develop exist in COBOL programs, Kix transactions, and the IMS transactions, right? So now the new modern tool, ZOS Connect, sits in between the outside world and these existing programs. It receives a REST API calls, convert the JSON request into a format, and the mainframe understands and then call the existing program. From a program points of view, nothing has changed. It still reads the DB2 vsam, runs the same logic, use the same security. Response, now the response comes back to ZOS Connect, while which converts into the JSON and sends it back to the caller. Whether that's a cloud app, whether that caller can be cloud app, mobile app, and the web application. So now what I'm trying to say is like now the data is not leaving the mainframe. Okay, what is changing with the help of the new tools we have, ZOS Connect. Okay, the access to how we are the access to the mainframe data, right? I mean, for mainframe nothing has changed. Okay, mainframe is still doing the same things, but with the help of the ZOS Connect, now the outside world can also see the mainframe data. Okay, with the help of the REST APIs, the JSON files, ZOS Connect will help in communicating between the outer world and the mainframe. Similarly, for in the security field, modernization is going on. IBM always supports, we know that pervasive encryption, hardware based security, but now there are quantum computers going to come, so we have to make sure that mainframes prepare for that, for the post quantum threats, because future quantum computers can break today's encryption very easily. So we are just not modernizing just for today. The IBM is not modernizing mainframe just for today, but for the next 10-20 years also. Okay. So we have many other analytics tools also now available, and that is going to getting used also. Instead of moving sensitive data uh, from the IBM platform to the another analytics platform, now IBM Z brings the analytics and the AI to where the data already lives, to the mainframe. Okay, we can use Apache Spark on IBM Z. I will not go in detail, but I'm just saying that we can have those features available in the IBM Z now. DB2 analytics accelerator, Hadoop connectors, these all things can be used in the IBM Z now. Okay. So DevOps, CI, CID on IBM Z, this is also very critical. Um, what DevOps gives to us, the culture, the speed. Now the IBM Z also wants the same culture and the speed, okay, that the cloud team enjoys. And DevOps on IBM Z brings the same culture and speed. So instead of, many developers will agree with my statement now. Instead of keeping the COBOL code in the mainframe libraries only, right? It can now be stored in the GitHub, GitLab. Developers can use VS Code plugins for the ZOS, or the Eclipse also can be used, right? So code, commit, build, test, quality gate, deploy, monitor. This is the pipeline. This all is now achievable on the mainframe platforms. For the build, we are using DBB. Code, we are putting it in GitHub. Commit, we are doing, okay. Uh, test, quality gate, we are building the Jenkins pipelines. All those things is getting happening on the IBM Z. So this is the future now. So we believe in this. And there is one more thing, modern and legacy must coexist. If a new API gateway fails, the old green screen, which I love, still works, right? So this is about very short story on modernization. How is it going on the mainframe side? What is ZOS Connect? What is Zoe? Again, a modern, which is again a very highlighted word nowadays. uh, Source framework developed by many other organizations that give developers a cloud-like experience on IBM. I think many of you are using it also. The Zoe and ZOS Connect now. It gives command line interface for the ZOS, WebView APIs, works with Git, VS Code automation tools very easily. Zoe modernizations how people interact with the IBM Z. So if you see the slide, that was just story on the mainframe, where mainframe is heading. It's not about we are modernizing the mainframe. More mainframes are already modernized. We are now just using its capabilities and the features we have. Okay, so bringing mainframes closer to the cloud. Mainframe and cloud should work together to have a very good environment for a organization. That's the best approach we have in the market now. For not market, maybe for the organization. Okay, if you see that modern ZOS tools and automation, it's just about I mean, so we know about automation. What automation does? Automation reduces the human mistakes, especially during pressure situations like incidents or IPLs. One wrong command at 2 a.m. can cause an outage, right? So automation is needed. Is the need of the time again? Modernization is needed, need of the time again. Automation is needed. Automation ensures the same procedures run the same way every time. Okay. Why this matters? This matters because no dependency on who is on call, no variations between sysprocs, predictable system behavior, fast execution, automated procedure execute instantly. No waiting, no typing, no delay, faster incident response, and less business impact. So if someone asks me, is automation risky? I will say uncontrolled automation is risky. Control automation with approvals and monitoring is safer than the manual operations. Okay. And in modern ZOS environments, automation is not optional. It's a necessity for reliability, speed, and scale. So uncontrolled automation is risky, but control automation with proper thought process, with proper approvals, and with proper monitoring is safer than the manual operations or the manual command. So automation versus manual control. We all know automation is fast. Humans are not fast with respect to automation, but they are careful, right? So and ZOS environments need both. As we say, automation is used for repeated task, health checks, monitoring, uh, standard recovery actions. But manual control is needed when systems don't match the rules. Risk is higher. Business impact is unclear. So I will say automation handles 80%, system programmers handles the rest 10, just 20%, where automation cannot also uh, uh, predict that behavior or resolve that error. Then the system programmers will come into the picture and with their deep knowledge, expertise, that situation can be resolved. So we need both. Okay, that 20% is where the experience matter. So modernization is not rewriting everything. Modernization is a journey. Treat it as a long time journey, a journey with you that will remain with you. It's not a one time project or 1 year project or a five months project or a 3 months deadline. It's a journey. Okay, ZOSMF Prabal will help you in explaining the ZOSMF. Uh, for a system programmer, ZOSMF did not replace system programmers. It just they're replacing the green screens with the help of ZOSMF. Now we have a web UI. Okay, Ansible is the new JCL for the mainframe. Okay, automation handles 80% and humans handles the risky 20%. I will again say that is key 20%. Okay, so ZOS is no longer isolated in modern environments. System must react in seconds, not minutes. so so we are hearing the terms, right? Ansible is the new JCL, Ansible is the new JCL. It's all over. It's all over there in the LinkedIn. In if you talk to any mainframe expert, he will say, okay, oh, Ansible, yeah, Ansible is the new JCL. So this is the shift from the console to the code. Okay, API driven operations turns the ZOS into the programmable infrastructure. So I will not go much in deep, but we already figured out REST APIs, DevOps ready, hybrid cloud. Okay, what are these and all those things. So now Prabal will help you with the next slides.
Sure.
Thank you, team.
Yeah, thank you so much, Saurabh. Just a moment, team. Let us switch our seats. All right. So thank you so much, Saurabh. I think it was quite intense for you. Team, I'll take it along from here. This is Prabal. So now we have learned a lot this morning after previous session about firstly about the SMP in detail, then the modernization, how is it happening, the modern tools which are getting integrated with mainframes and GOS, and the some of the tools he mentioned about like Zio, SMF, Z Connect, Zoe, etc. All these terms you have been hearing a lot. We'll touch them in this session, and if needed, you can connect offline and we can discuss about them in detail too. Right? So to progress further, let us understand this thing, which is quite important, is the amalgamation or collaboration of developers and system programmers, right? It is certain that the effective collaboration between developers and system programmers is instrumental in ensuring applications are designed, deployed, and operated within platform limits and business priorities. So on ZOS, success is never about developers or system programmers alone. It's about how well we work together, right? Developers and system programmers sit on two sides of the system. Developers focus on what the business wants, that is, the outcomes from the applications. On the other hand, system programmers focus on keeping the platform safe, stable, and available, right? If either side works in isolation, systems may fail, if not immediately, possibly afterwards, eventually. Okay. So, and there have been instances where there have been conflicts between the two sides of the story, the developers and the system programmers. And what our take is, most conflicts don't happen because people are wrong. They happen because priorities are different here, right? So to understand it this way, a feature that works functionally but overloads the system. Example, say a REST API, for example, you are using ZOSMF in any new system, you are using the REST APIs which are consuming a lot of CPU. So, right, that would flag something which is not considerable for a system programmer, because if the CPU consumption breaches the threshold, it could be a problem for the system, right? But developers may think, what's wrong? I've just deployed a new API and I need that to function continuously functioning. So right, so these things do happen, and then they need a conflict resolution appropriately, given the business needs in place. A security change, for instance, can break an application altogether, right? So we also have to be careful while performing any changes that they do not impact any applications which are required for the business to function properly. Okay, next one, please. So now let us understand. So now this is towards the end of the sessions. This is the final last section. And here I'll be mostly talking about the philosophical nuances of the system programming profile, and how they interact with the other peers of them, and how they cater themselves to fulfill the business needs, right? So, how does a modern system programmer evolution has happened? How the system programmers have evolved over the time? Ever since most of us started our careers, we must have heard somewhere or the other about mainframe and its roles going obsolete, right? I'm sure most of you would have heard when we started our careers about a decade ago. We from the outside world, there was always a noise that, oh, you have started it, but we have heard that mainframes are going away, and that has been the case with our system, our seniors. I, we used to hear the same stories from them also, because when they started the career, they also heard the same. It has been going on for the past 2 3 decades, and still it is the one of the most relevant machines on the universe, and it is running the business as it has been doing for ages. So contrary to what people think outside about mainframes becoming obsolete, or the role of a system programmer getting obsolete, the role of a system programmer has not disappeared or is not disappearing, rather, it is evolving with time. Earlier, the focus was only on keeping the system running, but today the focus is on running it smarter, faster, and safer. So, if you look at the timelines, it shows how our skills have evolved, right? So traditional deep ZOS internals, um, manual operations have been, I mean, that's the maximum level of adoption we have to have in our skill set. Then we also have to learn some tools which are very important for us, namely, say, SMF, RMF, JS, SDSF, or SMP for that matter. Then we also have to go along with in the automation journey. Less manual work, fewer efforts, and get a hold on the automation tools, like ops MVS, BMC, MI ops, etc. Right? And then we also have to become cloud ready in our skill sets. How ZOS is integrating with distributed platforms, etc. Right? And also DevOps ready alongside of it, like deploying the APIs, pipelines, faster changes, tools like Ansible, Terraform getting integrated these days, right? And then there's a requirement to become a full stack owner of the system, understanding the system, the applications, and the integration with the outside world or the modern tools and techniques, right? So this is how the skill development timeline looks like. You might be wondering why I've kept the full stack at the lowest and the traditional at the topmost priority here, because um, the core still remains most important. We must understand what's happening actually inside the system, what's happening beneath, and all, and then we can understand all the peripheral areas around it, right? So now let's see how systems have evolved. You can see on the right side of the screen, the section where I've mentioned there have been changes in regards to three areas majorly. First is the induction of modern tools, for example, ZOSMF. So Saurabh asked me to mention a bit about ZOSMF. Whatever he mentioned in the SMP session today, a large part of it has got modernized with ZOSMF. What ZOSMF is, it is a web-based tool. You can get it installed on your US systems, and it gives you a web link. You can access it from there, and it gives you a better new age UI which you can use, and you can interact with the systems. And so SMP process, what Saurabh explained today, there is a something in GOSMF called as PSI, Portable Software Instance. You have to create a new PSI, and using that you can, it will give you, just like Windows installation, it give you steps like next, next, next. It will ask you some inputs. You have to uh, give those inputs to the system, and you can go along and complete the installation. So it has certainly made our lives easy, but again emphasizing that we have to understand what's happening in behind. That's why the traditional knowledge or the core knowledge of the system programmers come into place, right? So ZOSMF um, sh- are surely replacing many green screens. It has got modern UI, portable software instance, automated manual processes, etc. Um, so, so first part is induction of modern tools like ZOSMF in our day-to-day activities. Now, second thing is the automation is the new normal in today's world. Repetitive work is getting automated, like sort of covered in his slides. OpenMVS, AMI Ops. I'm not sure whether you have heard of these tools, but these are the tools which have been in place for ages, for quite some time now, and they do help us a lot in in automating the processes. Or, for example, say if you want any of your batch jobs to run any particular time, then you can get them included in the automation script so that they can run at a given time or date, or say day of a week, right? And third one is the integration with cloud native and DevOps technologies is the new normal. I guess we have already explained this in the previous slide. So today's system programmer is not just a caretaker, rather is an integrator. Okay.
With ZOSMF, right, Prabal? So SMP is still happening in the background, but now the modern system programmers, traditional system programmers will do the things from the scratch. They will go to the vendor, ask the file, place the package, download it into a system, and then do the SMP process right from the beginning. Receive, apply. They will build the jobs with their own hands. Okay, they will mention the CSI names, what sysmods we needed. We will The traditional mainframe system programmers were doing it with their own hands. But now with the help of ZOSMF, right, we are just replacing the green screen and we are just having the UI. You will click the buttons, same things will happen in the background, but you are not going to see it. You can see it, but the you will see more the UI. But this core concept remains the same.
Right.
It's not you are doing it now manually. You are doing it with the help of a tool called ZOSMF.
Right, right. And to add to what Saurabh said, nowadays there's a strong push from IBM side to start adopting ZOSMF. In fact, from 2.5 GOS onwards, IBM make it kind of mandatory for system programmers to use GSMF for the OS install and for the maintenance install, and not just for GOS but also for the subsystems, CICS, DB2. Nowadays, people are doing it
No,
largely on this USMF. There are ways to
yeah,
do
yeah,
it,
correct.
do it without it as well, but IBM has been recommending it very, very strongly to start adopting GSMF from 2.5 onwards.
I think even developers can also use that. I am not very much confident in this, but uh, but 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 if any developers needs any test kicks reasons, right, or he or she may not reach out to the system programmers now and will submit a ticket, and then the next day system programmer will come and then he will create a test region for his or her applications to test and all those things. These things are gone now, I believe. With the help of the ZOSMF system, developers have the access. They can create a test regions, do the testing, and you can bring down the test regions or delete the test region, whatever you want. Or you just need the mainframe ID and password and a ZOSMF access. All things can be done by the developers itself. So ZOSMF will also help the developers to reduce the dependency of the system programmers, or maybe a very much time taking task. All those things have also been reduced.
Right. Okay, so we have so far covered what has evolved over time, what has got modernized, and what has changed, but also and always to remember, not to forget, that what has remained unchanged. Um, I could think of these four things for sure. First is the 24 by 7 mindset. No matter how modern the tools are, the systems still run 24 by 7, and the responsibility stays with us. Second is the ownership of the risks. If something breaks at 2 a.m., automation doesn't take responsibility, but we do. And the next one is availability focus. Now, say new features, new versions, and improvements are important, but keeping the system up and running 24 by 7 all the time, 365 a day is the most important task we've got in our hands, right? And the continuous vigilance. A good system programmer is always monitoring the system even when nothing looks wrong. So to summarize this, tools will change, automation will increase, but the core of system programming remains the same. Protect the platform, protect the business, and stay ever ready. Okay. Um, Now let's talk a bit about the future of system programmers. I think we have largely covered the modernization aspect of it, the automation, how it is getting integrated, the new age tools and techniques, DevOps, cloud, APIs, etc. So we have fairly covered it. I guess we can move on to the next one, which talks about the invisible platform. We are already knowing I mean, we all know how capable these systems are. This largely talks about the mainframe and GOS capabilities. We are all well versed of it. So let's move along, and I guess these are the few last slides here. Um, One key takeaway for all of us, I guess most of us are mainframers, some bidding mainframers. So for us, one key takeaway is the mainframes matter in today's world. They are the critical systems. They are scalable. They are secure, proven, modern. We all know. And if I could move ahead, some key takeaways in terms of the system programmers. System programmers build systems that the businesses can safely depend on. Okay, and the role requires deep technical expertise, not in one area but across many: GOS internals, performance, storage, security, automation, etc. System programmers deliver value to businesses, keep the business running, protect data, enable innovations safely. It's a demanding role, but it's a role that truly matters. So if someone asks you someday, or any of you being a system programmer, if somebody asks you, is this role still relevant? Then I would say yes, as long as businesses need systems that are secure, scalable, and always available, system programmers will always be relevant. Um, Now, this is just a skill distribution of system programming. I guess we have already covered this fairly, of the importance of all the service lines in the infra world, be it the performance and capacity, security,
We covered it part one.
right? We have already covered in the previous session, storage, change management, etc. So, with that, we have kind of come to the end of these sessions. This is a final thought which talks about the platform promises, like it gives us 99.999% availability. There are some unsung heroes who are worth recognition, those who work in the background. Billions of transactions happening every day. Um, there could be users those who don't know what's happening behind the scenes, but there's a lot, and the 24 by 7 responsibility, right? So over the last two sessions we have talked about hardware, operating systems, IPLs, maintenance, SMP, outages, on calls, modernization tools, techniques, etc. But none of this is really about technology. It's about the responsibility, the huge responsibility what system programmers have on their shoulders. System programmers are the people who think about failures before it happens, so the businesses never feel it. When systems work, nobody asks how, but when it fails, everyone asks why. The best day for a system programmer is not when they fix a major outage. It's when nothing happens and nobody even notices. Every stable GOS system has a story behind it, even if no one ever hears about it. With that, big thank you to all of you. Um, Sort of, you want to add anything?
No, thank you very much, all. So if anyone has any question, you can reach out to us for anything, the basic thing. If you want to learn anything, if you want to get guidance on anything, or if we can also learn from you,
Right.
we will definitely want to learn. So thank you everyone for joining and attending the sessions on the
System programming.
system programming on the two consecutive Saturdays we have.
Right, right.
So it's very good. So we enjoyed it. I hope we were able to deliver what was the expectations. But still there is a lot more on the system programming. It comes with the practical exposure, with the practical experience. But yes, we can learn anything
Correct,
every day.
correct. And like Saurabh said, I mean, think of it this way, it's a career for us, and not just us, but also for our peers who are in DB2 CICS, right? So covering everything in two sessions isn't practically possible. We have tried our best. If there are any things which you think have you want to know, so like you said, we can connect offline anytime. You can reach out to us LinkedIn, or you have our Gmail, our email addresses as well. We can connect over there and learn along with each other.
And thank you very much, Senthil, for organizing this. And
Right.
we are uh, we are good now.
Yeah. Thank you. Senthil?
Senthil has texted he had to step out. So
Oh,
Okay.
yeah, Prabal and Saurabh, I'm an app dev myself. Okay, so
Mhm.
I'm one of the people who insisted Senthil to conduct this kind of session.
Okay.
So the divide that I used to talk with Senthil between sysprogs and app devs is that, like, I don't know about sysprogs, but as an app dev, I never knew the language in which I need to talk to my sysprogs. So I
Mhm.
think this
that's
session gave a gateway to, like, knowing certain basic things and going to them with reasonable asks and stuff. So thank you so much for the informative sessions.
Thank you
thank
so
you,
much.
Namrita. I guess we had a good conversation with you in the part one also.
Right,
I
right.
think there were some good questions from you. Ask, I remember.
Right. Yeah. Thank you so much, Navneet. It was indeed our pleasure to give these sessions. And again, re-emphasizing we can connect anytime if anybody has any other questions. Are there any questions, or if not, I guess we are good to wind it up.
Thank you, Saurabh and Prabha.
Thank you, Savitri. Yeah.
Thank you.
Anurag, Anurag, you can reach out to me or Prabal. We will help you, or maybe we can guide you on that question you have, right? How to see the datasets which are getting impacted in the report section of the job when you
Sure,
run the
sure.
apply check. It's very easy. It's just that we don't have the screen in front of us, so we can't able to show you. But if you go it one time now, I mean, you can see it in the down. You have some datasets there, and you can realize it from there what are the data sets are getting impacted. But just remember, with some PTFs, all target libraries can be impacted, but with some PTFs, only one target libraries can be impacted. So it varies case to case.
Right.
Okay, okay, yeah. Okay, sir. Okay.
Yeah. Thank you very much, team. I am stopping the recording now. So if anyone has anything, reach out to us. Keep learning.